in aviation. For a helicopter pilot, transition is a crucial word. It means changing how the helicopter flies. It's about going from a hover to forward flight, or from forward flight back to a hover. Imagine a helicopter hovering like a hummingbird. To move forward, it can't just suddenly fly straight ahead. It has to tilt forward. This tilt directs the lift, creating forward thrust. That's transition. It's a delicate dance of controls and aerodynamics. Getting a helicopter off the ground and into a stable hover is an art. The pilot uses the collective pitch control. This lever changes the angle of all the rotor blades together. Increasing the collective pitch generates more lift. The helicopter starts to rise. The pilot uses pedals to control the tail rotor. The tail rotor counteracts the torque of the main rotor. This keeps the helicopter from spinning. Section 4, Dynamic Rollover, a Whirlybird's Nemesis. Helicopters can be vulnerable during takeoff. One danger is dynamic rollover. Imagine the helicopter tilting too far on the ground. Gravity wants to pull it over. If the pilot isn't careful, the helicopter could roll over on its side. Pilots train to avoid dynamic rollover. They react quickly to any tilting. They use the cyclic control stick to level the helicopter. They also manage engine power to stay in control. Section 5, from hover to horizon, transitioning to forward flight. Once the helicopter is in a stable hover, the pilot can initiate forward flight. This is a critical phase in helicopter operation, requiring precision and skill. The transition from hover to forward flight is not just about moving forward, it's about doing so smoothly and efficiently. This involves a smooth transition. The pilot must carefully manage the controls to ensure the helicopter moves forward without any sudden jerks or instability. A smooth transition is essential for maintaining control and ensuring passenger comfort. The pilot uses the cyclic control stick. This is the primary control for managing the helicopter's direction and speed. By pushing the cyclic stick forward, the pilot initiates the forward movement. This tilts the main rotor disc forward. The rotor disc's tilt is crucial as it changes the direction of the lift force generated by the rotors. Tilting the rotor disc directs the lift forward. This creates thrust. The forward tilt of the rotor disc is what propels the helicopter ahead, converting vertical lift into horizontal thrust. The helicopter starts moving forward. This forward motion is the result of the combined actions of the pilot and the helicopter's aerodynamic design. As the helicopter gains speed, the wings start providing lift. The faster the helicopter moves, the more lift is generated by the wings, reducing the reliance on the rotor system for lift. The pilot adjusts the controls to maintain a smooth, controlled flight path. Constant adjustments are necessary to respond to changing flight conditions and to ensure the helicopter remains stable and on course. Section 6. The Science of Flight Aerodynamics and the Whirlybird. Helicopters, often referred to as whirlybirds, are fascinating machines that defy gravity with their unique design and capabilities. To truly appreciate how they achieve flight, we need to delve into the principles of aerodynamics that govern their movement. Understanding helicopter flight means understanding some aerodynamics. The rotor blades are the key components that allow helicopters to lift off the ground and maneuver in the air. These blades work by creating differences in air pressure, which generates lift. Ground cushion is one effect. This phenomenon occurs when a helicopter hovers close to the ground, creating a cushion of air beneath it. When a helicopter hovers close to the ground, the air pressure increases. This increased pressure provides additional lift, making it easier for the helicopter to stay aloft without expending as much energy. This creates extra lift, making hovering easier. Pilots often take advantage of this effect during takeoff and landing to ensure smoother and more controlled maneuvers. Inflow roll happens because of the way air flows around the rotor blades. As the helicopter moves forward, the airflow changes, causing the rotor blades to experience different forces. This can cause the helicopter to roll slightly. Pilots must constantly adjust the controls to counteract this rolling motion and maintain stable flight. Flapback is when the rotor blades flex up and down. This flexing is a response to changes in aerodynamic forces acting on the blades. This can affect lift and stability. Pilots need to be aware of flapback to ensure they can make the necessary adjustments to keep the helicopter flying smoothly. Translational lift is the extra lift a helicopter gets as it starts moving forward. This occurs because the forward motion increases the efficiency of the rotor blades, allowing them to generate more lift with less power. Understanding these aerodynamic principles is crucial for both pilots and engineers. It allows them to design better helicopters and fly them more effectively, ensuring safety and performance in various flight conditions. Section 7. Mastering the machine from complexity to instinct. Learning to fly a helicopter is challenging. There are many controls and factors to manage. Pilots go through rigorous training. They learn about aerodynamics. They practice maneuvers in different conditions. With practice, flying a helicopter becomes second nature. Experienced pilots make it look easy, but it's a testament to their skill and understanding of these complex machines.